Okay, so next I'm going to show you how to write shorthand electron configurations. But first, I'd like for us to write the longhand for neon and silicon. So let's go ahead and do that, and I'd like for you to try it on your own. So if you pause the video at this point and then try to write the longhand for neon and silicon, and then press play and pick up and see if you got it right, okay? For neon, we're going to write his electron configuration. So notice that neon is right here. He's in the second energy level. He's in the P block. So we're going to go all the way to neon. So for neon, you should have written 1s2, 2s2, 2p6. And that would be the longhand for neon. If you add up your superscript, 6 plus 2 is 8, 9, 10. Remember, you can always check. Your atomic number should equal to the sum of the superscripts if you've done it correctly. All right, let's do silicon next. Silicon is located in the third energy level. And notice it's right here. It's going to end on a P2. He's in a P2 location. So for silicon, you should have written 1s2, 2s2, 2p6, 3s2, 3p2. You add these up. 2 plus 2 is 4, plus 6 is 10, 11, 12, 13, 14. We have 14 electrons here. And if you look at silicon, he's atomic number 14. Okay. So hopefully you got those right. If not, review back over this. Maybe review back over the lesson on the longhand that I posted earlier and maybe practice some more. But what I want you to notice, and I'm sure you have all picked up on this, that we keep repeating these patterns over and over again. If you compare these two electron configurations, you see that we've written the very same thing down up to the 2p6. Also, remember, neon's a noble gas, and they're the stable elements. Those are the elements that have full valence shells, and that's the element family that every element wants to be like. So when we do our shorthand configurations, our noble gases are going to play a significant role in how we write them. All right, so here's what you do to do the shorthand. Here are the steps. Find your element on the periodic table. I'm going to be going back up to silicon that we just did in the last example. But so we'll find silicon. You want to look in the period above it and then find the noble gas in that period. Then you're going to write the noble gases symbol in square brackets. From there, you will finish the electron configuration. So the shorthand for silicon, I'm going to come back up to what we just did. And I want you to notice the steps I just outlined. I said find the element on the periodic table. So we would find silicon. Then I said look in the period above it. So go to the period above it and go all the way to the end to the noble gas. You're going to put that noble gas symbol in square brackets. What that does is represent all of the electrons up to neon's 10 electrons. And then all you have to do is finish the electron configuration from there. So for silicon shorthand, it would look like this. You would put neon in square brackets, and then that would represent all of these electrons here that we've already done, where we copied the same thing over and over. That's what the square brackets represent around neon. And so now you just finish it from here. You're just going to end up writing this down. 3s2, 3p2. And if you wanted to check them, you could still check them the same way. You just have to say, okay, how many electrons did neon have? If you look at your periodic table, he had 10 electrons. And so then just from there, add up the other superscripts. 2 plus 2 is 4. So 10 plus 4 is 14 electrons. You're still representing all of the electrons. But what we're representing here specifically that we're writing out, again, is the valence electrons. And remember, they're the ones that are participating in bonding. They're the ones that are going to be gained, lost, or shared. Okay, so that's shorthand electron configurations here. Okay, I hope that helped clarify. Let's do a couple of examples with our shorthand. Okay, so in your notes we see aluminum, nickel, ruthenium, chlorine, and we have europium. I'm not going to do all of these, but I think I'll pick nickel, ruthenium, I'll do chlorine and europium. All right, let's look at nickel first. Find nickel on the periodic table. Nickel is here in the D block. I'm going to scoot out just a tad. Okay. Nickel's on the D block. Go to the period above it and go all the way to the noble gas. So we're going to put argon symbol in square brackets. Okay, let's write that down. The argon symbol in square brackets. This represents all the electrons up to the 18th electron, which is argons. Now you're going to finish your configuration from there. Remember, this is your first, second, third, fourth, fifth, sixth, and seventh period, and the D's are 3, 4, 5, and 6. And remember also the F's are 4 and 5. And don't forget the helium lives beside of hydrogen. So these are just some reminders. All right. So we just wrote argon in square brackets. So we're going to pick up from there. And remember, we're going to nickel. So you'll say 4S2, 3D, 1, 2, 3, 4, 5, 6, 7, 8. So that'll be what we finish up with. 4S2, 3D, 8. And that is nickel's shorthand electron configuration. All right. Hopefully you followed that. Let's look at another one. Let's find ruthenium. Ru is ruthenium. Here's ruthenium on the periodic table. Point to it. It's not very clear. All right. Go to the period above it and go all the way to the end. Krypton is who we're going to put in square brackets. So we're going to put Kr in square brackets. And from krypton, we're going to pick up, once you leave krypton, he's element 36. So that means we're now on the 5th energy level. 5s2, 4d, 1, 2, 3, 4, 5, 6. So we're going to finish 5s2, 4d, 6. And that's ruthenium. Okay, pause for just a moment and try the next two, and then mash play and see if you got those right. I'm going to go ahead and finish. Chlorine. Here's chlorine. Find the noble gas in the period above them. You get neon. Finish it from there. So after neon, you would say 3s2, 3p, 1, 2, 3, 4, 5. So we're going to put neon in square brackets. And then from there, 3s2, 3p, 5. All right, let's find europium, EU. Now this one's going to be a little tricky because I want you to pay real close attention to something. I'm going to zoom in on this and remind y'all of something. Here's europium right here. All right, well, he's in the F block, and you've got to remember, y'all, where your F's come in. All right, he's element 58. Well, cerium is. Look where the 58 actually fits. Okay, 57, and it jumps to 72. Your F block fits in right here. Now we're still following as a roadmap, and I think of this as like a detour. You know, sometimes I do road construction, and you'll get to a spot and you have to turn and take this very long detour. Well, that's what we're going to have to do here. Now europium is in the 4 F's. So to figure out what noble gas to use, you just track it back up. This is where he fits. That's where the 4 F's will actually fit into the table. So if you look in the period above this, you're going to go all the way to the noble gas and the end of the 5th period, which is xenon. Okay? So we're going to put xenon in square brackets. Now after we leave xenon, we're going to then pick up here. So we're going to follow the map again. 6s2, 5d1, and that's where the detour happens. Come down here, 4f, 1, 2, 3, 4. I forgot who we're going to. Hold on. Europium. Okay. Let me come back up here. So 4f, 1, 2, 3, 4, 5, 6. He's a 6-1 over. 1, 2, 3, 4, 5, 6. So after you put down your noble gas xenon, 6s2, 5d1, because there is that one lanthanum there, and then scoot down here, 4f1,